In this lesson, we'll examine some strategies to consider when answering quantitative comparison questions. These strategies involve approximation techniques that can help us solve questions quickly. At the heart of these techniques lies a very important rule. Do not perform more calculations than are necessary. Remember, the GRE is not meant to test your ability to perform tedious calculations. It's meant to test your number sense. So if you find yourself carrying out lengthy calculations like this, then you're probably wasting time. In many cases, we can avoid time-consuming calculations and use one of the approximation techniques covered in this lesson. Now, the first technique we'll examine uses some simple estimation with a twist. Consider this question. To solve it, we'll apply the formula for finding the area of a circle. Since the radius of the circle is 5, the area will equal pi times 5 squared, which evaluates to be pi times 25. Now at this point, we could replace pi with approximately 3.14, and from here we could multiply 3.14 by 25 and then compare the result with quantity b. However, this would be much more work than is necessary. Instead, I'd like to introduce you to some notation that you'll see throughout this course. Rather than replace pi with 3.14, we'll replace pi with this. Here, the floating plus sign tells us that we're dealing with a number that's bigger than 3. From here, we can see that if we take a number bigger than 3 and multiply it by 25, we get a product that's bigger than 75. And if we compare a number bigger than 75 to quantity b, we can see that quantity a must be greater. So according to the answer choices, the correct answer here is A. As you can see, we were able to solve this question without performing any lengthy calculations. This will typically be the case with GRE math questions. Now, when it comes to using approximation to solve quantitative comparison questions, another useful strategy is to compare the quantities in parts. Here's an example of how this strategy works. As you can imagine, we do not want to add all of these values together. Now, we could try using approximation here and see if that works. However, we can solve this question even faster by comparing the two quantities in parts. Here's how it works. Let's first compare these two numbers since they're relatively close in value. As you can see, this number is bigger than the other. When we compare these two numbers, we can see that this one is bigger. And finally, when we compare these two numbers, this one is bigger. So all three numbers in quantity A's sum are greater than all three numbers in quantity B's sum. As such, quantity A must be greater than quantity B, which means the correct answer here is A. Okay, let's try another question. Now you may want to pause the video and try this one before continuing. Okay, what should we do here? Well, we might begin by recognizing that this fraction is very close to 1/2. Now, is it bigger than a half or smaller? Well, 125 over 250 equals 1/2. So 123 over 250 must be less than 1/2. So we'll replace this fraction with a number a little bit smaller than 1/2. In this instance, the floating minus sign here tells us we're dealing with a number a little bit smaller than 1/2. On a similar note, this other fraction is very close to 1/3. Now 3003 over 9009 equals 1/3. So 3003 over 9047 must be less than 1/3. So we'll replace this fraction with a number a little bit smaller than 1/3. When we apply similar logic to quantity b, we see that this fraction is a little bit bigger than 1/2, and we see that this fraction is a little bit bigger than 1/3. From here, we can compare the quantities in parts. When we compare these two fractions that are close to 1/2, we see that this one is bigger, and when we compare these two fractions, this one is bigger. Since both numbers in the quantity b sum are bigger than both numbers in the quantity a sum, quantity b must be greater, in which case the correct answer here is B. Okay, let's look at one last question. For this one, we'll apply a useful technique at the very end. Once again, you may wish to pause the video and try the question before continuing. Okay, first let's replace these cumbersome values with nicer ones. This number is a little bit bigger than 130,000, so let's write this. Similarly, this number is a little bit bigger than 480,000, so let's write this. In quantity B, this number is a little bit smaller than 260,000, and this number is a little bit smaller than 240,000, so we'll write this. From here, we can see that all four numbers end with 4 zeros. So let's just drop those zeros and compare these simpler values. Now at this point, you could choose to multiply these values and then compare the two products. But there's an even faster approach that you can do in your head. It involves a useful rule that we'll examine in a different module. It says that the product of A and B is the same as the product of 2A times 1/2 B. Now, why would we want to apply this rule here? Well, notice that if we multiply 13 by 2, we get 26, and when we multiply 48 by 1/2, we get 24. This suggests that our rule here might make our two quantities look more alike, and this could come in handy. So to apply the rule, we'll multiply this number by 2 to get a number a little bit bigger than 26. And then we'll multiply this number by 1/2 to get a number a little bit bigger than 24. From here, we'll compare the two quantities in parts. When we compare these two numbers, we can see that this one is bigger. And when we compare these two numbers, we see that this one is bigger. Since both numbers in the quantity A product are greater than both numbers in the quantity B product, quantity A must be greater, in which case the answer is A. Okay, that concludes this lesson. Let's summarize. In this lesson, we learned 3 things to consider when tackling quantitative comparison questions, and we learned some special notation that helps us when using approximation.